Let's work this next example paying attention to the process of working our way through any related rates problem. This question says, a water tank has the shape of an inverted circular cone with base radius 2 meters and height 4 meters. If water is being pumped into the tank at a rate of 2 meters cubed per minute, find the rate at which the water level is rising when the water is 3 meters deep. Now, the process for a related rates problem is to draw a good picture and glean all the information that you can out of the stem of that problem. Here's the stem, all the information that they give you. You want to glean all the information using really good notation that you can from those words. So the first thing they tell me is I have an inverted circular cone. So I know that my tank looks like this. There are some things that I carry with me from geometry about cones. I know that the radius and the height meet each other at a right angle. I know that the height, the radius, and the slant edge to the cone give me a right triangle. In this particular problem, they tell me that the dimensions of my tank are 2 meters for a radius and 4 meters for the height. So there's a good picture. If water is being pumped into the tank at a rate of, well, there are several rates. I can have a radius rate, a height rate, but the meters cubed is a very big hint that I'm talking about volume rate. So the rate at which water is being pumped into this tank is 2 meters cubed per minute. I know that this is a positive 2 meters because my volume is increasing when I am putting water into the tank. Find the rate at which the water level is rising. Let's get a different color here. Here's the water level. When I draw the water level in there, do you see that I have another radius, let's call it R, and another height going on this problem? I'm going to call it H. Those two again meet each other in a right angle, and once again I have another right triangle. This tells me that the rate at which the water level is rising, I am going to call dH dt. If the water level is rising, H is increasing, dH dt better be a positive value, and the units on that would be meters per minute. So I know that when R is 2, H is 4. I don't know what R is at any given H, but they want specifically for this problem to find the rate at which the water level is rising when the water is 3 meters deep. So there is the one instance where they want me to answer this question. This relationship is always true no matter what. The radius is 2 when the height is 4. So there's all of the information. There is steps 1 and steps 2 in our process for answering a related rates problem. So we want to make sure that we go through all the steps in this process. Step 3 is to find a relationship between all the variables involved. The relationship between the volume, the radius, and the height of a cone is the equation for the volume of a cone. The volume of any cone is 1/3 the volume of the cylinder. Any three-dimensional solid, I remember from geometry, the volume of that three-dimensional solid, as long as it was a right solid, and this one is the area of the base, which is a circle, times the height. So I have an equation that relates the radius, the height, and the volume of this cone. I'm going to rewrite it. I'm going to put my 1/3 and my pi together. That's just a constant coefficient to the product r squared times h. Step 4 of this process is to find a relationship between the rates of all the variables involved. In other words, implicitly differentiate the equation you found in step 3. So I'm implicitly differentiating in any related rates problem with respect to time. This tells me and confirms that I'm dealing with time. So the rate at which volume is changing with respect to time is simply dV dt. I have this constant coefficient, pi over 3, that I'm going to pop out front, and I have a product. I have r squared times h. So I'm going to need 1d2 plus 2d1. That is my product rule. Use excellent calculus. I'm going to call r squared 1 and h 2. So 1 d2, the derivative of h with respect to time, plus 2 d1. Please remember that r is some function of time that has been placed in the squared function machine. That is a composed function. The derivative of any composed function requires the chain rule. So this is the derivative of the outside, not changing the inside, times the derivative of what's inside with respect to time. So there's my derivative function. Now, I have several variables here. Let's count how many. There's one variable, 2, which is just repeated here, 3, 4, and 5. The one variable they want me to solve for is dH dt. That's how I'm going to answer this question. All of the rest of the variables, dV dt, r, h, and dr dt, I need to find a value for. It's the only way that I can say dH dt equals this. So what I'm going to do is go about trying to solve this problem. I need a value for dV dt. They gave it to me. The value for dV dt is 2. I need a value for r. They did not give me a value for r. Now, they did give me a value here, but that is the value when h is 4. What is the value when h is 3? I don't know that. That's the value that goes in here. That's the r squared we're talking about. I won't find a value for dH dt. It's the one variable I'm going to leave there. They gave me a value for h when h is 3. Again, I don't have a value for r. I hope to find it. And I don't have a value for dr dt. I hope to find that as well. So how am I going to find this value of r and this value of dr dt? I have to have them in order to solve for dH dt. I want you to notice something. We have not used this information yet. We wrote it down. Something I want you to remember about advanced placement questions, whether they're multiple choice or free response, the stem of the problem will never, ever, ever give you extraneous information. If they give you information in the stem of a problem and you did not use that information to answer your question, you have found the wrong answer. The process here is to use all of the information that they gave you in order to answer this question. And the relationship that when r is 2, h is 4 is extremely important to us. We can actually use the two triangles that we have and geometry to find a way to write r in terms of h and dr dt in terms of dH dt. If it is true that when r is 2, h is 4, Similar triangles say the ratio of the small sides of those two triangles must be equal to the ratio of the long sides of those two triangles in the same direction. I always did small to big. So we're going to use similar triangles from geometry. The small radius I have listed as r. The big radius is 2. That must equal the small height in the ratio to the big height. Here is the relationship between the radius and the height of this tank for any r and for any h. We could clean it up. R is always going to be 1/2 of h. When h is 3, r must be half of that. So everywhere I see a r, I get to write 3/2. Always a true statement. Always, always. That leaves dr dt. How am I going to find out what dr dt is in this problem? If I could, at the very least, write dr dt in terms of dh dt, I'm perfectly fine with having the variable dh dt remain in this problem. I'm actually solving for it. Here is the relationship between r and h everywhere in this tank. If this is the relationship between r and h, when I implicitly differentiate this equation with respect to time, it must be the relationship between the rates of r and h. Has to be. It can't help itself. So I may not have a value for dr dt, but I certainly can write dr dt in terms of dh dt. And that completes step 4 of the process for related rates. We're down to step 5, which is the algebra of solving this equation for dh dt equals. So let's clean this up a little bit. 2 equals pi over 3 times 9/4 dh dt plus, those cancel, 3 times 3 is 9 over 2, 9/2 dh dt. Now I have like terms. I have 9/4 dh dt's and another 9/2 dh dt's. If I was going to write this with a common denominator of 4, that would be 18/4 times dh dt. So 2, I'm going to go down here a little bit, 2 must equal pi over 3 times 9/4 plus 18/4 is 27/4 dh dt. Watch my addition and subtraction carefully here. If I'm going to make a mistake, this is where I'm going to make it. So I'm going to solve this for dh dt. dh dt must therefore equal 2 divided by, and I'm going to put these two fractions together, 27 pi, let me write that clearer, 27 pi over 12. Again, algebraically, I clean that up even more. 24 over 27 pi. Both of those values have a 3 in it. So 8 over 9 pi. What are the units? We have meters per minute.